So the two things I've shown you so far, MongoDB and Postgres, are very general purpose kinds of databases. As in, like, if you're going to be writing a new app tomorrow, decent chance you're going to use one of these two, right? They're meant to be very flexible. They're meant to fit nearly every use case. They're obviously very powerful databases. We're going to get into one that's a more specialized use case. So you're not going to use a graph database for your everyday e-commerce website, for example. You're going to be using it probably in conjunction with another database. You're going to be using graph databases with another database for the most part. So graph databases are more niche. They're more intended to solve a specific problem and less meant to be general purpose, right? This is not meant to power your e-commerce website. So the example that we're going to use today is kind of the classic graph database kind of example problem, which is movies and actors, right? And we'll kind of get into how that works. So let's get into some of the terminologies. Again, this is one of those things where like I use the terms interchangeably, and I'm very sorry about it, but it's also just kind of how this is organized in my brain. And it's probably useful for you to hear all of the terminologies mixed together, because that's kind of how it ends up working. So the first thing I want to talk about in a graph database is a node or an entity. The correct term for Neo4j, which is the name of the graph database that we're going to be looking at today, is a node, but sometimes you might hear me call it an entity. A node is just a thing. It's basically a row or a document in a graph database. It represents a thing. So in our case, if we're going to be looking at movies and people, right, those are going to be the two different kinds of nodes that we're going to have. Those are both going to be considered nodes, right? There's going to be a person node, and there's going to be a movie node. Something that's peculiar to Neo4j is one node can actually be multiple different things. So let's say instead of having just a person label, as they're called, you can have one person be both an actor label or actress label or director label. A node can have multiple different kinds of labels. In this particular case, the only two labels that we're going to be looking at today are persons, right, which will represent both actor, actresses, and directors. But you could also have a label for each one of those depending on kind of how you choose to solve that problem. And then the other label will be a movie, and a movie is kind of a thing, right? So you can think of nodes as documents or rows in a graph database. Now the interesting thing, and where graph databases really kind of get their power, is they have these things called relationships, or frequently these are called edges as well. The correct term for Neo4j is relationship. And it just describes this node is related to this other node, and we're going to draw some sort of connecting line between the two of those things. And we'll kind of visualize this here in just a second. But that's the power of graph databases, is you can describe this kind of graph, but like a web of relationships between different things. A really good use case for graph databases, and probably where they really got pushed forward a lot, is social networks, right? So you can imagine, like on LinkedIn, you're connected to this person's connected to that person, and that person's connected to that person. And that's how like LinkedIn knows how to recommend, is like, hey, you probably know this person because you know these 10 people, and they all know this person, and they're connected to him, and you're not. Decent chance that if so many people in your network know this person, you also probably know that person. So that's where these kind of interesting insights of connections can kind of lead to these insights, using these relationships. One thing about Neo4j that's, again, kind of peculiar to Neo4j is every relationship is directional, right? So it's not that just, let's use an example from a social network. On Facebook, when you are connected to someone, you're both friends. Like, you can't be connected to someone, you both have to acknowledge, we are both friends. That relationship has no direction, right? I'm friends with Mark, Mark is friends with me, and we can't have that be one way. Compare that to something like Twitter. If I follow, Aisha, right, she doesn't necessarily have to follow me back. That's a directional relationship. So in Neo4j, all of these relationships have directions associated with them. And And sometimes you can just ignore these directions if you don't really care about them, but every relationship is going to have a direction. So in this particular case, if we were describing the relationship between me and Aisha on Twitter, and we both follow each other, we would actually need two different relationships, one from me to her and one from her to me to fully describe that relationship. Whereas in Facebook, you just need one relationship because there's only one way that relationship can go. Cool. So there's things called properties or attributes. I probably will mix up those terms because they're relatively similar, but in this particular case, they're going to mean the same thing. Every relationship and every node can have properties associated with them, right? So, for example, if we're talking about like an actress, like we have, I don't know, Charlize Theron or something like that, she can have a birth date, she can have, I don't know, hair color, eye color, those will be attributes of that particular node. And then a relationship can also have a node. You can also have, if Charlize Theron acted in Arrested Development, that's what I'm watching right now, that's why it's top of mind, it can have like the role that she played in it. It can have the year that happened. It can have the episodes that she was in, right? So those are kind of the attributes that a relationship can have as well. So both entities and relationships can both have properties. So that's kind of the high-level terminology of what goes into a graph database. We'll start kind of getting into it and using them so it'll become a bit more concrete. We're going to be using Neo4j. That's kind of like the de facto, if you're going to use an open source graph database, it's kind of the one that people reach for the most, or at least it's the most well-known. There are other ones. There are other graph databases. There are, you can make MongoDB and Postgres kind of act like graph databases. There's a lot of different ways to accomplish it. And then there's obviously things like, again, Cosmos DB and some of those cloud-based graph databases that are available to you as well.